Begin. Dan, glad you're here. First of all, we'll introduce the folks on the call. Then we'll talk about two customers, CoreWeave and Starburst, and how they use Cockroach database for their metadata layer. Then Ron's going to do a live demo of the Cockroach distributed SQL solution. And then we have Q&A. If you have questions, go ahead and put them in the chat as we go along. We will follow up on those near the end when we have the Q&A section. You'll be getting a gift card. It's a Starbucks card, so hopefully you'll enjoy that when it arrives. And then if you have any interest in following up afterwards, we'll reach out and we can set up a discussion with you to talk about any use cases or questions you may have after the call. So my name is Owen Taylor. I used to be a Broadway performer in New York City. I was in a show called Cats for 6 years. And I was lucky enough to sing and dance all over the world. And then I had a baby boy and decided I needed to grow up. So I got into IT. For the last 3 decades, I've been doing distributed systems. I've been an architect, an engineer, an educator, and a seller. With me is Ron Nolan, who's a senior staff solutions engineer here at Cockroach. He's an expert in all things relational database related, and especially with the Cockroach distributed SQL solution. So he'll be doing the demo a bit later. If you're interested, join us in Las Vegas for Roachfest 2025, happening October 14th. And you can register free of charge using the RF100 code. Kelsey Hightower of Cloud Native fame, he's a speaker who does a lot of these Kubernetes conferences. He'll be speaking, discussing how infrastructure has moved from being something we're afraid of to something we can rely on. And that counts in terms of your database as well. We'll also hear from 3 customers, Cisco, FanDuel, and Squarespace, and how they use Cockroach to scale their systems globally and stay available and adaptable as things change. To be or not to be. Today, we're going to talk about 2 customer stories and really the greater story of the IT landscape and the heroes of IT. Folks like you, Dan, who keep the systems alive and running and humming and have to deal with tragedies, failures, system outages. The conflict makes for a good story, but honestly, we'd rather the story wasn't so good and that we had a little more stability. There are 2 measures that you may be familiar with, RPO and RTO. RPO being your recovery point objective, measuring how much data gets lost in the case of an outage, and RTO being how much time does it take to get back to a healthy state. And the goal, of course, is to keep those numbers small. The antagonist or villain in our story is the unprepared IT organization and infrastructure system that can't handle what happens in the real world to real systems. We did a survey of 1,000 companies early this year and discovered that on average, they experienced 86 outages a year. Now that's unplanned and planned. So a lot of that is repaving servers or scaling, making adjustments, schema changes, as well as things like disk slowdowns, network outages, fat fingering of various commands and issues that can come up. The average length of such an outage was around 3 hours, and the minimum amount of cost per hour was $10,000. The maximum was measured in millions. So clearly something you want to avoid. One of our customers, CoreWeave, is a major player in the AI landscape, offering up hyperscaler solutions for AI workloads. Dateline, March 2025. CoreWeave deploys Chaos, their AI object storage. This is an exabyte scale, S3 compatible managed cloud storage service. At that scale, you can imagine there's plenty of metadata, and they need some solution to make sure that metadata layer doesn't go down. Their reputation depends on it, as well as $30 billion in revenue backlog they have to deliver on as of June 2025. Their customers include Microsoft and OpenAI, so nothing trivial here, and the fear was palpable as they deployed. And of course, things changed. After they deployed, they found their application needed an adjustment in the database schema. And everything went better than expected because they chose CockroachDB, which allows you to make schema changes live without disrupting your application. So they made a change in the primary key on an important table with 1 billion rows and had 0 downtime. This is typical of CoreWeave's infrastructure, 0 downtime. They're so proud of their infrastructure, they actually have a page on their website that you can go to that reports in real time on the health of the systems involved. And of course, there's a layer there for their storage and the Cockroach layer. So what is this metadata we speak of? And how does CoreWeave use it? And how do other service providers and companies utilize metadata? So it's interesting because very often you as a company wish to offer to your customers some kind of access to either an application service or infrastructure service. In order to do that, you've got to keep track of how do they connect, who they are, what kind of privileges should they have, and what is the shape and type and life cycle of the underlying systems and data. And as we move into the world of AI, as I mentioned earlier, there's a lot more unstructured data. Unstructured data sounds great until you try to manage it. And then you realize you need a whole bunch of metadata to keep track of it and organize it and make it useful. So the metadata landscape is exploding. Who needs this metadata? Anybody who needs to get work done. Because if you can't figure out how to get connected, if you don't know how to be registered or how to identify meaningful structures within the landscape of your service layer as a client, as an application, system operator, business owner, decision maker, you're never going to move forward. So you need to know where to plug the wires in. You need to know how to audit the activities and keep track of the data that's involved. Oh, churn and fade the customers will do as IT ops supply bandage and glue. Each challenge tamed, yet pain throughout is felt. An outage to the application dealt. Earnings, dollars, and profits all denied. The street recalls each swollen, blackened eye. Oh, churn and fade the customers will do as IT ops apply bandage and glue. With all these things that can go wrong, are you stuck with limited tools at your disposal? Are you using bandages and glue? Well, we'd like to offer up something better, something that's a little more adaptable and scalable and reliable. And to speak to that, it's more like a summer's day. It just isn't true that you have to suffer anymore. You can exist in a world where your database has a 0 RPO and where RTO is measured in a few seconds. And that's where Cockroach Database comes in. And that's why CoreWeave moved from Postgres to Cockroach, because they had to scale to 30 regions around the world. And they needed to make sure that the performance met their SLAs. And that at the same time, they were using a transactionally sound database. Plenty of technologies can scale, but they don't remain consistent. So it's critical for many businesses to ensure that a change that happens in one location is reflected everywhere consistently. And they wanted to reduce the cost and stress of operating their metadata layer. They can do that in 2 major ways. One, by choosing a good technology like Cockroach, which is a distributed SQL solution that can scale across the world, and do that in a way that appears simple to the operator. In addition, they can use our managed service. By the way, we have a metadata layer for our managed service, and guess what? It runs on Cockroach Database because we have customers all over the world, and we have to scale and stay alive, regardless of what weather events might occur. Another customer, Starburst. They have a product called Starburst Galaxy, which is a fully managed software as a service offering of Trino, which is an open source technology that federates data. So if you have data that lives in CSV files and in databases and so on, and you want to combine them into one view, that's what Trino does. And then you can query it using standard SQL. But how do you turn Trino into a globally accessible service? Well, the obvious choice is to have a centralized metadata store that everyone can point to so they can find their information, both in terms of how do they log in and what privileges do they have, what catalogs have they created in the past, what views have they created, and also how do we audit what they're doing, both for monetary tracking and also for troubleshooting. So a centralized metadata store makes sense from a logical perspective. And in doing so, they can offer up a simple user interface to the end user, to the service provider. It appears to be a single system of record where catalogs are maintained and where users can manipulate the underlying data and organize it as they need to. And it is remembered for their next visit. So their CTO, David Phillips, was delighted to understand that they can use a distributed SQL solution like Cockroach, and it still feels like a single node Postgres deployment, because that keeps it simple from an application development and operations standpoint. Of course, in reality, the implementation has to be distributed because their customers are all over the world and their data is all over the world. And that creates a whole bunch of interesting challenges related to throughput and latency and management. They deploy in the US East, in Europe, and in South Korea. They need to be able to replicate the data to all those regions, have a single database that is accessible in all those regions. And they also scale up and out as needed when they have spikes in their activity, and then scale down and in when those spikes subside. So that's an interesting challenge to solve for. They also have to ensure that any changes that are made anywhere in the world are immediately, consistently visible everywhere else in the world. And that any rules that are part of the schema in terms of foreign key relationships and limits on data values and so on are all maintained, and you've got your relational integrity. And then, of course, that global challenge. How do we optimize the location of the data so that users in various regions get the lowest possible latencies? In addition, there may be constraints, regulatory requirements in each region in terms of where can we actually legally store user data. So we need a solution that can solve for that as well. And the protagonist of our story, the hero, is, of course, CockroachDB, which allows you to create a cluster that spans the globe and a database that spans the globe within that cluster, with tables that span the globe within that database, so that you as a user, as an application service provider, keep everything simple. It appears to be a single logical database. You connect to an endpoint and you talk SQL. Under the covers, it's managing all that complexity. Oh, churn and fade, the customers will not, as IT ops learn trust in what they've got. Each challenge tamed and framed in joyful ways. No outage felt despite trouble for days. Earnings, dollars, and profits all will grow. The street recalls this most impressive show. Oh, churn and fade, the customers will not, as IT ops learn trust in what they've got. So those 7 listed challenges on the left-hand side are pretty common. I imagine you may have run into some of those as challenges. They're so common that we determined it was necessary to make that part of our standard testing for our product. And we have, as part of our website, a page we call Performance Under Adversity, which is publicly available. You can execute these tests yourself, and we challenge other database vendors to mimic our results. What we do is we implement a whole bunch of chaos testing over 10 hours on a 15 node cluster, and we fail disks and network and regions, zones. We do backups. We turn on and off various expensive CPU activities like change feeds. We do schema changes. We do rolling upgrades. And we have 7,000 warehouses under load, continuously being beat up on during that time. And the results are excellent. You can go take a look at the page, but that blue line for SQL metrics mimics what the business application sees as it's executing its TPC benchmarks. You'll get occasional flickers in latency as the system suffers through some of these disruptions, but there are no outages during the 10 hours that we do this chaos testing. I want to turn our attention one last time to Starburst and really picture the world and the challenge involved in meeting SLAs when you've got users all over the planet and data that they need also all over the planet. The excitement that we have about our technology comes from this solution of being able to intelligently place.
On TMM. I told you we're all in on WebAssembly. We are also all in on OpenTelemetry. Where is Laurent? There he is right over there.
Hello. It appears that there's somebody on the call who may
very few
decide to mute. There we go. So Starburst needed to ensure that any call to the metadata layer was under 100 milliseconds from any endpoint that their service layer provided. This was necessary because a business operation that's part of the service layer may actually entail up to a dozen metadata calls to implement its logic. So clearly, they care deeply about making sure the customer experience doesn't end up being stretched to impossible lengths in terms of the amount of latency involved in setting up a catalog or changing something about their account and so on. So they were able to take advantage of our distributed SQL solution to achieve this goal by making sure that users in certain regions talk to endpoints that are co-located. As their CTO says, it's like magic. They were able to achieve their scalability demands of going out and in on demand, also keep their costs low. Because not only was it a good choice to choose CockroachDB, but they also use our managed service, which means all they have to do is declare their intent, either using our UI or using our API, and instruct us to scale on demand, add new nodes in new regions as necessary, and so on. So now it's time to see the magic at work. And I'm going to let Ron speak to the next few slides in preparation for his demonstration of this technology.
Hello, and thanks again for joining us today on the Use Case Café webinar. Welcome to the live demo portion of our presentation. As Owen said, my name is Ron, and I'm going to walk you through a little bit of CockroachDB's performance under adversity. So let's jump right in. The application that I'll be using is based on the ERD, the entity relationship diagram that Owen is showing right now. It's really simple. It's just a metadata example for something like buckets or a simple service, simple storage service. We've got, oops, can you go back really quick, please, Owen? There you go. We've got buckets. We've got objects in those buckets. So you might have, a bunch of files or some, something in those buckets that we want to have access to. We've got access rights for those buckets, and then an audit trail that we're writing to constantly as those objects are accessed. Next slide, Owen. The application technology consists of what you see here on this slide. Next slide, Owen. We have this is all taking place in US East 2 in 3 different availability zones, A, B, and C. Next slide, Owen. The cluster is running in all 3 of those nodes, all 3 of those regions. We've got a CockroachDB node running in US East 2A, 2B, and 2C. We've also got a load balancer. I'm running HA proxy, but in real production environment, you'll probably use something like a network load balancer. And finally, my application. My application is running my demo software. I'll be running the demo in 3 different sessions on the same application server, with each copy logged into a different node of the database via the load balancer. My plan is to demonstrate 2 frequently performed maintenance tasks that often require a database to be stopped or quiesced, right? And we're going to observe the application running against the cluster while we perform these tasks. The first task is going to be a patch. So we're going to take a node out of the cluster, patch it, and put it back in. And then we're going to finalize the upgrade. And then the second task will be to perform a schema change. We're going to add a column, a not null column, to a table that includes a default value. And all of this will be achieved with a 0 RPO, right? No data loss at all while we do all this. And for this demo, our RTO is actually 0 as well. All right, I'm going to go ahead and I'm going to share my screen. All right. So let's talk about what we're looking at. What we're demonstrating here is our database UI. If you're using our advanced product, which is our cloud product, or even if you're self-hosting, this is the database UI you'll be using to interact with your database to see what's going on. We're looking at the overview page here. You can see we have 3 nodes in our cluster, as I already mentioned, each one running in a different availability zone in US East 2, sorry. There's a message at the top of our window here. It's saying, hey, you're running multiple versions of Cockroach right now. So we've got 2 nodes running 25.2.4. So I've already patched 2 of the 3 nodes, and we got 1 node running 24.3. So one of the things we're going to do is patch that node up to 25.2.4. We can see we've got 3 live nodes, no suspect nodes, no draining nodes, and we've got 63 total ranges. None of them are under-replicated or unavailable. In addition to that overview screen, we also have several dashboards that I want to walk through really quick. We've got our overview dashboard. So here we can see our SQL statement P99 for everything that we're running. This includes the selects and updates and inserts that I'll show you in a second. We've got a hardware dashboard where we can see CPU, memory, disk I/O, and throughput. And one more that I'm going to show, because it'll be interesting to see this when we take a node out and see what happens. This is our replication screen where you can see what's going on with replication in your cluster. So that's the UI and the dashboards. Here, these SSH sessions, on the top, I'm actually connected here to my database node, my node 3, that's running in US East 2B, the node that I'm going to patch. And on the bottom are 3 sessions. That's my application executing. So you can see the average latency for each one of the statements that I'm performing. You can see I'm connected to 3 different nodes, node 1, node 2, and node 3. So my load balancer has, as I connected via my application, my load balancer distributed the connections across all nodes in my cluster. I have 3 nodes. I'm connected to all 3 nodes. So I'm going to patch this node that's running currently 24.3 to 25.2. So the first thing I'm going to do is I'm going to stop my database. And you can see my application here got a quick message saying, hey, I've detected a disconnect. I'm going to reconnect to a node. Now I'm doing what's called a drain as I bring this node down. So the application, as it cycled through, it knew to get a new connection from the connection pool as the node was brought down. If we go back to our database UI, we can see we have 1 node draining and I have 63 under-replicated ranges. Nothing is out. I've got under-replicated ranges. but my application in my database continues to execute. So here is my database UI. Let's go back and let's actually apply our patch. And it's going to automatically restart the database as well. So what we should see is the message about our database being at different versions has changed, right? It now says all nodes are running 25.2 because I patched that node, but the cluster is still on running on 24.3, meaning I haven't finalized it yet. So at this point, if I wanted to, I could still revert to 24.3, even though I'm running the 25.2 binary everywhere until I finalize. Once I finalize, all bets are off. I have to stay at the version I'm on. My nodes are all back live. I have no more under-replicated ranges, so my database came back, and as we can see, now all nodes are running the same version. I want to show metrics quick here. The overview. We saw a slight bump in P99 latency when we performed the upgrade, but no outages, right? My application continued to operate, my P99 came back down, and my average latencies are back to exactly where I expect them to be. In fact, if we watch these closely, we probably never saw our average latencies change at all. Let's go ahead and actually finish our, excuse me. Let's finish our upgrading. So we can see that the cluster is currently on 24.3, and I'm going to go ahead and actually finalize that upgrade, which means no more going back to 24.3. That'll take a couple seconds while we do that. You can see that my average latencies are holding across all my application nodes. And if I go back to my database UI, I should reload this. And the message will be gone about me being on multiple versions. I'm finally at one version, shown up here, 25.2.4, and all of my nodes are running that software. Okay, so that was how we patch a node. Now, in this demonstration, I stopped the node, I patched it. Maybe I repaved the node based on my security or compliance requirements, and then I brought the node back into the cluster. I did that for the existing 2 nodes so that we didn't have to walk through that whole thing in this demo. But it was the same thing that I did on the other 2 nodes, nothing special. That's it, no downtime. So great way to be able to patch a database without ever having to bring it down. Okay, one more thing we'd like to do is we'd like to go ahead and make a schema change to a table. So I'll show you the statement here that I'm going to run. So I'm going to alter that buckets table that we saw in that ERD. I'm going to add a column called secondary owner. It's going to be string, and it has a not null constraint on it. And so the default that I'm going to add is unknown. So all the existing records will have an unknown value for that column. What the database is going to do in the background is it's going to make a copy of that table in the background. It's going to apply the change in the background. And when everything's finished, it's going to bring that table to the foreground. No writes are going to be lost. No updates are going to be lost. That table we keep DML right on that table as it's going. And the database will take care of switching that for us. And we'll see that when I look back at the database UI, we can look at what's called the jobs screen. Okay, that happened really fast. So I'm back at my database UI. I'm going to look at this job screen. And so here's my alter table statement. You can see that it succeeded. It was a fairly large table, so that happened pretty quick. And you can see I've got something else here, garbage collection for alter table. So remember I said that what happens is the database makes a copy of the table, updates the new copy with the new column, and then brings that table forward. The original table is still existing in the background. There's a job that's going to garbage collect that for this database. It's set to 4 hours. And while that table is still there, before it gets garbage collected, I can actually run selects against it. So I could actually look at that old data before that table was moved to the background. That concludes our short demo of CockroachDB's performance center in Versity. So we saw a database patch to a major upgrade applied and a schema change, all with no downtime and 0 RPO. Remember, like a cockroach, CockroachDB is hard to kill, runs everywhere, and it survives anything. Back to you, Owen. Thanks.
Terrific. Thanks, Ron. I think at this moment, before we switch back to saying goodbye, we want to open it up to any questions that some of the attendees may have. So your screen is still live there, Ron, just in case some of those questions are related to the demo and the environment there. Does anybody have any questions they'd like addressed? Going once. You are muted potentially, so you may have to ping us in the chat if you want our attention. All right, I guess we did a great job of explaining how this all works. Oh, there we go. All apps in 1AZ seems bad. That's a comment.
Yeah, and for this demo, I did just use one application server, but certainly in a production environment, you would have application servers running in multiple AZs so that if an entire AZ failed, your database and application would continue right on running, right? And that's how Cockroach is designed to run. But for the simplicity in this demo, we just attached one application server via a load balancer so that we could see that kind of operation. But great point. Yes, that does seem bad.
Yeah, in the diagram that I showed, there was a global load balancer that routed according to the latency measures of each region, a particular service client to its nearest local load balancer, which then picks from one of the 3 nodes that are in your region. So it's actually sort of a chain of command. Once you're established that you're talking to your local region, then you stay there until something fails. Hopefully it never does. But if it does, you can always go to a different region if necessary, although more likely your application would have a similar life cycle to the actual underlying database. And the comment comes back. Ah. Yep, you're correct. Earlier in the presentation, I think I spoke to the nature of our solutions that customers are using us in global settings and that they care deeply about co-location between the database instances and their service layer. All right, I will go back to my desktop and see if I can find my presentation. There we go. So in closing, thank you for your comments. Do we have any more there? Is there something else in the chat? Ron, are you able to see if there's anything additional?
Yeah, I don't see anything. It was just an all good comment.
Excellent. All right. Well, once again, do plan to join us if you like in Las Vegas. We'll be having this very intriguing session with Kelsey Hightower talking about a cloud native database, which is CockroachDB. Kind of a bit of a brain teaser how a database could be cloud native, meaning there's no master nodes, everything is equal, and you can kill them off and not worry about your database going offline. Just going to check the chat again. Ah, great.
That's me.
Kelly's giving the code. All right. Well, thank you very much for attending. If there's no more questions, I want to thank you for your time today and wish you success. We'll be following up and checking in to make sure that if you have any interest in this technology, you'll have access to it. Bye-bye.
Thank you.